All right, welcome back to Computer Science E75. This is lecture 5 sequel, where we finally introduce an actual database engine. And what I thought I'd do is motivate today, or maybe even demotivate, by showing a little something I worked on last week, actually. So apologies that I wasn't able to join you. Hopefully you enjoyed last week's look at all things XML with David Heitmeyer. But at the time, I was in Virginia in a hotel room, actually, and at least after 5:30 p.m. And I had been inspired by having gotten a note a few weeks prior from some person on Harvard's campus who suggested, hey, we've seen that you've been doing things like Harvard News, the news site that I think I pulled up a couple of weeks ago. It'd be nice if someone put together a Harvard Tweets site. So there's this thing called Twitter. I am not among those who tweet. Perhaps some of you are, but there's a whole lot of people at Harvard that apparently do. And I had no idea until I started Googling around and trying to figure out who was actually using this system. But thus was born in this hotel room Harvard Tweets. And I introduced this today because it's purely implemented in PHP using a little bit of MySQL and really all skills that you'll have by the end of the semester. And I thought I'd give you a taste of how this was implemented just to give you a sense of some of the things you might bite off yourself for your own final projects. And realize that we're only about halfway through the semester. We still have a couple of projects left, so there's plenty more to learn. But essentially, we have this PHP-driven site. Everything happens within the confines of this one page. So in fact, much of the underlying code is just in, say, an index.php file, and then some ancillary files that have some functions I wrote. On the left-hand side here, we have all of the names of people on Harvard's campus that have Twitter accounts, at least that I could find, or who informed me of their accounts. In the middle here, we have all of the so-called tweets, 140 character or less posts that have been made by people on their cell phones or computers or whatnot. And then on the right-hand side, we have, just to fill some space with pretty colors, we have everyone's icon. And then just last night, actually, I was really struck by this little flash animation. You may have heard of the notion of a tag cloud. Well, this is sort of literally a cloud of tags. So these are all of the key words that people have labeled their tweets with. Previously, I just had this as one big HTML list, but frankly, I thought this was so pretty. Maybe not necessarily the most useful UI, since you have to kind of catch the thing as it goes by to actually click on it, though you can slow it down. But this is a flash animation, and the person who wrote this open sourced it. So I looked around at their code, I looked at the parameters he had defined for, and essentially I feed that flash file, a .swf file, a string of XML, with which you're now familiar, and it uses that XML to generate this spherical thing, which I can then hover over. Things will slow down for me, and if I want to see who's talking about interesting topics, surprisingly many on Twitter, all of these people use the word interesting in some form. You then see a filtration of the data based on that keyword. So what this thing does is not so interesting for us, but how it does it instead. So I set out to do the following. I knew that there existed this thing called Twitter. I knew people had screen names on Twitter, or usernames, and I needed to figure out a way to get the data into my own database so that I could create a Harvard searchable version of Twitter. And I didn't really want to resort to this thing called screen scraping. So screen scraping is this very annoying process of writing code in PHP or any other language that mimics the behavior of a browser and makes an HTTP call of some website, grabs all of the HTML and maybe JavaScript, CSS, and all of that junk, and then parses it top to bottom, left to right, and then looks for data of interest. So what do I mean by this? Well, Twitter has their own website, even though I gather most people interface with Twitter via phones and other mechanisms and other websites altogether. But you can search here. So if I do something like Harvard, I could have simply hit enter here. Notice I could have stolen the URL, much like we've been doing with our imitations of Google and the like. And I could just, with some PHP code, once in a while execute this query on the command line, grab back all of these web page results, and then assume, perhaps, that all of these people are somehow affiliated with Harvard, so I could screen scrape this data. Well, how do I do this? Well, to me, the human, it's very easy to realize that, okay, this is the so-called tweet or message. This thing in blue is the username, and this thing is the icon. But if you've ever looked underneath at the hood of most websites, I mean, the HTML, odds are, is a god-awful mess. Now, hopefully it follows some structure, because even messy though it may be, odds are it's been generated by a computer program on that end, so hopefully there's a pattern that you can leverage in order to figure this out. Well, I could have right-clicked and viewed source, and then, oh God, I need to write a program now that analyzes this file and extracts the information. And this is frankly what a lot of people do, and it's what you have to do. One of the teaching fellows for another course I teach implemented a really pretty website 2 years ago, crimsondining.org, if you'd like to take a look. And this site does actually resort, out of necessity, to screen scraping to grab the day's dining hall menu for breakfast and lunch and dinner. He integrates that data into his own database and then presents it to the world in a much more machine-friendly format, being the computer scientist though he is. I thankfully had the foresight or the fortune to Google Twitter API, Application Programming Interface, and I noticed, oh, thank God, these people actually have an API. So they have functions, they have a library, whatever you want to call it, with which you can interface to actually perform machine queries to get back data of interest. So I clicked on this link here, Twitter API documentation. I was a little overwhelmed at first because, frankly, I did not need to know or care about all of the crazy things you can do with Twitter, but I cared about searching, for instance. So I click this link here, and it turns out that Twitter supports, much like a lot of websites these days, something called a REST API, R-E-S-T. And this isn't a terribly specific term. This generally means that you can grab data by executing queries, but those queries are simply URLs. And they're URLs with certain parameters, like Q or output or whatever the keywords are, that tell the server what data to return. And you'll get back, for instance, JSON, which is something we'll talk about in a couple of weeks' time, JavaScript object notation. Sometimes you can get back XML. Sometimes you can get back CSV. Sometimes you can get back HTML itself. It really depends on what those folks have decided to expose. So Twitter happens to support something called Atom, which is similar in spirit to RSS. It's an XML format, so very easily parsable, just with the simple XML API that we've used already. JSON, which is actually very easy to parse as well. There's one function in PHP called JSON decode. It will hand you a PHP associative array, which is wonderfully powerful. And you can pretty much choose which formats you want. I think I chose JSON just because it was a little simpler. And what I determined was that I can, by following this documentation, execute queries like http://search.twitter.com/search.json and then question mark and some parameters, one of whose parameters is username, for instance, or Q, and such things. So what I wrote behind the scenes was I never had to go to Twitter's own website again. I instead wrote a PHP script that sits in a loop and iterates over all of the Twitter usernames that I knew of and executes one of those HTTP queries per user. What I'm returned is a big associative array containing all of the user's recent tweets from the past, 24 hours or 48 hours. I then iterate over that array, insert those elements into my own database, enter today's discussion, and then when you actually see this page by visiting in your browser or executing a query on my site, I never again ask Twitter for those results because I've cached them locally. And what this means is I can design my database tables in a way that lets me search fields in a certain way. I can even do trending over time. Once I have more than 2,400 tweets, maybe I'll do some filtration, like allow people to filter out stupid things that they never want to see. Some of the undergrads that I teach in another class joke today that to some extent this site is being overrun by a website called Harvard FML. You're familiar with the acronym, so we might have to start filtering these people out. If you've never heard this term, Google it, perhaps not at work, and you'll see what it means. But this is some of the things. So by the lack of chuckles at all, I can tell no one in this room knows what this means. I should not pronounce it on camera. Similar in spirit to RTFM, WTF, if you're familiar for some of those acronyms. So figure out what the keyword there is. What's that? Oh, is it there? Okay, we'll fix that in post-production. If I don't see it, it's not there. Oh, but it's here. So long story short, this was sort of a 2-night PHP project for me, at least. I sat down the first night and started musing. I read the API. And then that night I had enough energy to design my database table. So I thought about, in the context of SQL, what data do I need to capture? What do I need to store? Things like their screen name, their tweets, maybe their full name for the left-hand side here, their icon. So there were different pieces of information, and I wanted to think about how best to design my databases. And I dare say that that's one of the fun aspects of actually playing with a real database. Similar in spirit to what you did with your XML file for Project 1, but you have more sophisticated, more technical decisions you can make when you're actually using a real database engine. And then the next night I sat down to actually write the code that grabbed the data, presented it in a fairly simple way, and supported searches and so forth. So it's a few hundred lines lines of code or maybe 1,000 lines of code. But at the end, it's a fairly simple interface, but demonstrative of what you can do with fairly basic programming chops and some familiarity with the concepts of today and the weeks to come. Yeah?
You're saying you're caching all of these entries. So I don't even know if this is possible with Twitter, but if somebody deleted a Twitter entry that they did and it's like, you would still have it, right?
Oh, yes. Yes, no, if someone, and to repeat for camera, if someone deleted some message on their Twitter feed, if that's possible, it would not propagate to me, partly intentionally, not because I want to have this Wayback Machine of all of their offensive tweets, such as number 2 up there apparently, but really it was for blacklisting reasons. So I was very frustrated in like 2 a.m. in the middle of the night that I'd gotten myself blacklisted from Twitter's site or my IP address because I was hammering their server too many times. And then finally I read the fine print as to, should not hit them more than 200 times per minute or something like this. So then I had to insert delays and whatnot. So that's actually my technical justification, is I can't really afford the risk, so to speak, of hitting them so often to go back and get past data. But we could certainly. Other questions? Yeah?
Are the usernames of these things stored in the database as well?
Yep, they are. So I need to know what the usernames are because actually once every 5 minutes I decided I have what's called a cron job, which is something you can play with on CS75.net. Cron is a system in most Linux or Unix machines that lets you run a command at a specified hour or on a schedule. So I wrote a little one-line cron job which says run this script of update.php once every 5 minutes, and it's in that file. So I didn't implement all of my PHP code in a web-facing file. Some of it is just a command line script that gets executed every few minutes. And yes, what that script does is it queries my database, as we'll see tonight, give me all the usernames, then it iterates over each username, executes, I think we're now up to 150 or so screen names, get each screen name's JSON data back, just cache it in my database, and then render it for users. Yeah. Oh, same answer. Okay. Other questions? So, to be honest, I kind of delight in things like this because it's increasingly easy to do interesting things with fairly minimal effort. And I know it doesn't feel like minimal effort when you've spent 30, 40, 50 hours on something like Project 1, which at first glance felt like, oh, this seems easy, pizza website. I know these things take time, and even I did not intend to spend night number 2 on this project, but kind of leaked over. And then I guess last night was night number 3 with the little integration of that. But it's fun, and thanks to entities like Twitter, and we'll see later in the semester Google, who have really done a nice job at providing a rich set of APIs and functions, you can really, for me, honestly, in the past year or two, like programming has actually gotten fun again, because you can do such interesting things with data. So more on that in the weeks to come. Any other questions, though? No? Okay, so let's turn to this. So a word on Project 3, and I think I'm preaching to the wrong folks here, so I'll focus there for a moment. So Project 1, 2, and 3, as promised weeks ago, are not meant to be done the weekend before it's due. These are meant to be 3-week projects, 10 hours here, 10 hours there, 10 hours there, so 30-plus hours of work amortized over several weeks' time. So let me at least make a plea with Project 2, because we certainly saw a spike of emails and bulletin board posts and phone calls this morning in particular. Like, it's fairly clear that in many of those situations, we could have dealt with these problems Friday or Thursday or Wednesday or Tuesday. So please do yourself the favor of keeping the expectations of these projects in mind. And frankly, they can't be fun if you're working on them the night before or 2 days before. I am sure it takes the fun out of it, and that's really not the point. Just to give you a sense of what to expect, each of the PDFs alludes to the 3 axes along which the projects are evaluated, but we try to do things fairly coarsely so that we can focus more on qualitative feedback and less on quantitative feedback, which is not all that enlightening to staff or students. But we have these 3 axes. Correctness speaks to how well do you meet the requirements. Did you correctly check off each of the boxes? Is your code free of bugs and the like? Design is more of a subjective axis, whereby we try to push as many students as possible toward better designs. So realize at the start of the term, with this real first project, getting 3s and 4s and 5s on correctness is really good. And frankly, if you're getting 1s and 2s on correctness, I mean, you're really not reading the print closely enough, or you ran out of time and didn't finish things properly. Design is something where you should expect to get 3s in the beginning of the semester, maybe even a 2, so that we, the staff, actually have a role to play toward pushing you towards 4s and 5s. do not equate 3 out of 5 with a 60% and thus a D grade. They mean nothing in terms of letter grades. Take them for what the qualitative labels there mean, poor, fair, good, better, best. Style, meanwhile, speaks to the aesthetics. Is your code well commented, indented? Is it easily readable, and so forth? And there, too, if you're doing a poor job or fair job on style, I mean, that, too, is very easily fixed. I mean, it's design that's really the interesting one and the one we hope to really provide some good feedback throughout the term and throughout on the projects. Yeah?
So if I have to read those through, A of 5 and E of 1, is the course grade then a summation of all the points I could have been earning?
No, there's no one formula. There's no predetermined distribution of grades. There's no official curve per se. Everything is very much subjective at the end of the semester, where we take into account trending from students from start to finish, the teaching fellow's perspective of their interactions with the students. I mean, it's meant to be a very organic process. And again, don't equate A with 5 and an F or E with poor, because if you do that, all of you are about to get C's or something like that. And I don't think that's a good mental model to have. This is why they are not equivalent to letter grades. So good is good. That is a bad comment to say, perhaps. Okay. But do realize, per the X factor on the left-hand side, because getting correctness right does inevitably take more time than, for instance, commenting your code and indenting it properly, realize that correctness is weighted at a factor of 3 typically, or more than something like style. So realize that if you're leaving off comments here and there, you're not going to be penalized as much for just missing a whole page of requirements on, say, the project. But again, it's meant to be a learning process. We care more about the qualitative experience, not the quantitative. Okay, so today's about databases. And it's not really the first time we've talked about this stuff, because we've played with a few formats already. So one, and the most obvious perhaps, is XML. For this current project, which just went out the door this morning on the course's website, Project 2, CS75 Finance, will you implement an E-Trade-like website, whereby you'll create usernames and passwords, or empower users to do so. Upon logging in, a user can then get a stock quote, and they can then get the current price of Google or Microsoft or any publicly traded stock. And if they click then a button, they can buy, quote-unquote, shares of that stock, sell shares of that stock, and then ultimately get a summary of their portfolio's current value. So, in fact, some of you already eagerly, it seems, discovered such right on the home page. We have the so-called big board. This is really just a fun aspect to the project. It's been very interesting running this course over the past several months with all the financial goings-on, because most people's portfolios were kind of like this in the spring semester, which is kind of funny to actually see our fake website really showing the trends in the real world. Some of you are already doing fairly poorly over the course of just 6 hours today. Down 2%, but some of you have also made $28 or so. So what these folks did, if you haven't played yet, is if you follow this link on the website to CS75 Finance, we have a staff implementation of the project. You're welcome to look to it for inspiration as to how did we implement this feature described in the spec. You'll see our HTML, of course, and CSS and that stuff, but you won't obviously see the PHP code. That's left for you. But what these folks did was they clicked the appropriate link when you go to CS75 Finance, where you can play the big board. We then deposit into our implementation 10,000 virtual dollars that you can then trade by clicking and following the on-screen directions. If we pick on one person here, Gilbert, looks like Gilbert bought Constant Contact, CTCT, 550 shares at at 1807 a share. Here is his history down here, but unfortunately the price has gone down by 37 cents already. So we know this because we kept track in our database of when Gilbert bought the share, the date and time, and the quantity, and the price at that moment in time. And what we're using is Yahoo Finance's own, and API is a very generous term here, API for nearly real-time stock quotes. So the story here to tell is much briefer than Twitter's. Let me go to finance.yahoo.com and now motivate the next several weeks' projects. It's always distracting bringing up news sites, but let me quickly do something like Goog, G-O-O-G. And, once upon a time, frankly, when the project was being designed, I really wanted to do something with finance, with stock quotes. And I didn't really know where we were going to get stock quotes. Couldn't really afford a Bloomberg account for everyone. So we went to sites like this and Google. And we noticed on the right-hand side there, download data. So that was interesting, because that's what we wanted for this project, students to be able to do. So I'm looking over here on the right-hand side, download data. So I hovered over that for a moment, and now notice at bottom left, though rather small, it's a download link. Oh, interesting, .csv. So it turns out it's not so much an API because there's no functions you can call, no methods. Frankly, there's no documentation even. Sort of nice people on the internet have figured out what the various parameters have meant. But essentially, this is a REST API because it's URL-based, and I can make queries of this URL, get back the equivalent of an Excel spreadsheet, which I'll do in just a moment, and then using PHP and using some of its built-in functions, can I then iterate over the rows and columns of this Excel file and grab the price that I want, the stock name that I want, and any other fields related there too. So let me go ahead and click this download data. And now notice, because of the MIME type they're spitting out, it didn't download in this case to Excel, just spit it out to my browser, but you can see the commas there, which do imply a comma-separated values file, CSV. To make this more clear, let me actually go back, and let me control-click or right-click and do Save Linked File As. Let me go ahead and save it to my desktop here. And then we have quotes.csv, and if I double-click this now, it will open Excel. Because CSV files are just text files, but Excel takes it upon itself to assume that it knows how to display them. So here we now have in rows and columns that same file. Now it's kind of a silly spreadsheet because there's only one row, but per the spec it turns out, or if you look around at unofficial documentation, you can actually request multiple quotes at once. And this is what we in the staff implementation do for the big board so that we're not making 100 queries every time we update our prices. We get every student's portfolio at once. But notice in the left-hand side, we have the stock symbol, probably the price here, the current date and time, and then some other information here, which I'd have to consult our own URL, but we could correlate these with the websites, probably high and low and bid and ask and metrics like those. So what did we, or how did we do this? Well, or what will you do with this? Well, the URL again looks a little something like this, and if I zoom in here, we can pretty much infer what some of this stuff is doing. So quotes.csv, even though it looks like a CSV file, turns out it's a script that's spitting out data dynamically. The question mark in the middle there means here comes the parameterization. S, presumably a stock symbol, so we could very easily concatenate that on as we've been talking about already. Ampersand F, turns out the F is the format string, so that's the most cryptic part. And thankfully, people have documented, and we put in the PDF for this week, the unofficial, non-exhaustive list of all of the parameters that are supported. You really, for your project, will only need one, like the stock price, but you'll see, and we include them because there's some really fun, juicy details in there. And then this last thing is partly a hack, as far as I know. Ampersand E equals .csv. At least back in the day, there were various browsers that if the URL did not end in the file extension, it would not understand exactly what was coming back. So I believe this is a historical hack for tricking the browser into realizing it is, in fact, a CSV file. Browsers these days are a little more sophisticated, though, thankfully. So, long story short, you're going to use that data and implement something that is a little like this. And this is purely opt-in. If you worry that you're going to be way down here, that's quite fine. You don't have to click that link. You can still play with the you can still play with our implementation without broadcasting your investing skills or lack. So, what does it mean to be a database? So in XML and in Project 1, you kind of had a database, but you didn't really have a dynamic database. It was very much static, and except for the fact that, yes, the pizza guy could actually change it with Notepad or TextEdit or whatever tool you happen to leave him with. But we could have had you storing data in XML format for Project 1. It's just we decided that email was essentially going to be your database. So once an order is placed, you sent off that email, and voila, order placed. And that's perhaps reasonable, especially for simple websites where you don't want to waste the time implementing a back-end database that's going to store data persistently. It's just not necessary. You're never going to need the data again. Frankly, shooting off emails and letting a human actually interface there might very well be reasonable. But just as PHP comes with XML reading functionality, so does it come with XML writing functionality. And you use the same API, simple XML API. There are some functions you probably didn't touch that would allow you to insert nodes and insert attributes into your XML object. And then there's an asXML function that would turn that object in memory, that DOM, back into an XML string, which you could very easily write to disk with a function called like file put contents is a popular one. So several different ways in which you could have written XML. We're not going to do that in this particular course because now we're at the point with this website that it's time to grow up and start using a real database. Now with that said, there's some middle ground. And for instance, though we'll discuss SQL tonight and MySQL, a specific database engine, there's also sort of intermediaries like something called SQLite, which we'll talk briefly about, which gives you the illusion of an actual database against which you can use this thing called SQL and execute fairly sophisticated queries like select and insert and delete and all of this. But there's no database per se. It's just a text, it's a binary file in your current working directory that's exposed to you as though it's an actual database. And I've used this for some projects where I want to write the project, I want everything to be encapsulated in one folder that the owner can even zip up and move to another server and not have to worry about a database username, password, server, any of that. So it's actually a really nice trick, frankly, for small, for low-load websites, certainly some of the projects I've done. CSV? Yeah, you could use CSV to store things in a database. The upside of it is it's so damn simple. But it doesn't really support structure. As you saw with Excel and can imagine, Excel supports rows and columns. And if you can imagine any more sophisticated structure, something with nesting, so to speak, or something that's hierarchical, like an object in memory, like a DOM, it's really hard to serialize complex objects into rows and columns. And this is arguably one of the weaknesses of the databases we'll spend a lot of the term talking about, relational databases, which boil down to rows and columns. They're not object-oriented databases, but they can be made to work if you follow some guiding principles, some of which we'll talk about today. And we'll focus in particular on MySQL. So MySQL is a company, but they are also a free product called MySQL. They've got a community edition and then the version that you can pay for, and with it comes some human support. It's very high performing. Facebook is known to use it for much of their infrastructure. Other popular websites use it as well, and it's a very credible choice even for industry and for private companies to use because, one, the price point is so appealing, frankly, compared to tens of thousands of dollars for things like Oracle and the like. It's fairly high performing. It scales laterally or horizontally very well, as we'll discuss later in the term. And it's very popular. In fact, if you go out after this course and sign up for a web hosting account somewhere that gives you databases, 9 times out of 10, frankly, it's going to be MySQL. So it's just that popular. But there are alternatives, and some of the buzzwords would be PostgreSQL or Microsoft Access or Oracle or, shout out your favorite database name here, SQL Server, and a bunch of others. Now, many of them do use the same, almost use the same language, structured query language, SQL or SQL, but often do the database engines, the implementations of these databases, support special extensions or special keywords that not all of them support. So for the course, we'll try to focus almost entirely on language that is universal across all implementations, but that's one of those things to beware if you move from one system to another, that some of your code might break if you were making assumptions as to functionality on a given database engine. Okay. So what's a relational database? Well, here is a screenshot of Microsoft Excel. So a relational database is one that stores its data in rows and columns. Not just in one table, maybe, but in multiple tables. So Excel spreadsheets even have multiple worksheets. You can think of each of those as a separate table. And so when you create a database for Project 2, you can think of it, if it helps, that you're creating a big Excel file that has one or more worksheets. Each of these worksheets will henceforth be called a table. And the fun part of database design is in deciding what should your columns be called and what data type should be in them. And then the second big question is, what data belongs in which tables? Because very often might you be tempted just to put all of your data in one table, but you'll start to see redundancies. For instance, and quick aside, if you're implementing any kind of like mail program or address book program, anything that needs to keep track of people, what's a piece of information you might record about a person in an address book in real life? Name? Email address? Phone number? Home address. Oh, keep going with that. Home address. What does that include? Street, city, state, zip code. So let's pause there. there's a few pieces that are already probably redundant. Email addresses, probably unique. Names, pretty unique. City, 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 city. If you have a lot of friends in Cambridge or Boston or Massachusetts, if you imagine typing all of your friends into individual rows, you're probably going to see Cambridge a lot, or Boston a lot, or certainly MA for Massachusetts a lot, maybe the same zip codes. So this hints at one of the opportunities for database design, for normalization, as it's called formally, whereby it's inefficient space-wise, and conceptually it's just stupid to have the same data again and again, because very often might a piece of data change, and it's ideal, just in principle, consider CSS, to change it in one place and not to have to change it, for instance, in everywhere in your database. And especially for a database, if you're storing CAMBRIDGE for every person, I mean, that's 9 or more bytes for every person, that could really be reduced to 1 byte or 4 bytes if you use an integer or number to represent that city-state uniquely. So this just hints at some of the design opportunities and what you can start to do when it's not just XML or CSV file at your disposal. So what's MySQL? So it's a database engine. This is the fancy term for these things. What does that mean? That just means it's a piece of software that runs on a server. So if you say a database server, a database engine, a database, these are all kind of synonymous, but if you're really anal, you can start to draw lines between some of them. A server is often a physical device, but a server can also be a program running on a physical device. For our purposes, and really in real life, all of these things are interchangeable. So we have a database now, or database engine, and this is a piece of software that's interesting, and more interesting than an XML file, because it is in fact a program that's running. And just as your web server is a program that's running and is resident in your physical machine's RAM while it's listening for connections on port 80, same deal for database engine. It's better than, for some definition of better, things like CSV files and XML files, because those are files that live on disk. And anytime you want to interface with them, you do an fread or equivalent, you read it into RAM, you analyze it, maybe change it, you write it back out. Every time someone interfaces with that database, you're doing the same thing. And some of you felt this inefficiency conceptually in Project 1. It's kind of stupid that if you have a very popular pizza website, that every thread handling a customer is reading that same XML file into memory again and again and again. It literally is being replicated in RAM, because in PHP out of the box, you don't have the notion of shared memory that you do in something like an application server, like a Java servlet or JSP. So you don't have that in PHP. And even the session is an illusion. You could, some of you were tempted to put your menu, once parsed from disk, put the DOM into your session. But that doesn't mean you're sharing it across all of those users. You're actually, ironically, putting it back on disk, just in a different file, in the /temp directory for the session file. So in PHP, there is that weakness, unless you start to use an actual database, something that's running. You double-click it on startup, or run it at the command line when your server boots up, that's listening for connections. So MySQL happens to use a port, just FYI, of 3306 TCP by default. So any firewall issues might need to poke holes in that. Realize now that, again, for this project, you're welcome and encouraged to develop on your own machine, Mac, PC, using XAMPP or any of these client-side products. You won't, for security reasons, be allowed to connect to CS75.net's own MySQL database, because we firewall it off, because most MySQL traffic is unencrypted by default, and it's a bit of a pain to get it to be encrypted. So you would develop on your servers, then you would move your database over to the server when you're ready to test it at your actual domain name. So realize you can't talk to us on this port. In fact, we only let in 22 and 80 for the most part ports. Okay, so this little screenshot here hints at the most simple interface possible that you can use to talk to a database. So I'm going to go ahead and do exactly this. Let me go ahead and open a terminal window. And we'll start with this more arcane interface, then turn to one that I think pedagogically is a lot more compelling. Let me go ahead and log in to my CS75.net account using SSH. Okay, so now I'm at my command line here. I'll zoom in a bit further. And I'm going to go ahead and do MySQL, enter. And by default, you'll get an error message, most likely, unless your restrictions on your own server are different. But we can infer what this means pretty clearly. username Malin at localhost using password no. Probably I need a password. So just some of the very basic tricks, which generally I think is a pain. It's a pain to use MySQL's command line interface because it's just not very powerful at all. But sometimes, and on some servers, it's necessary. So we'll give a quick few teasers here, useful syntax, and then we'll transition to the more sophisticated approach. -p will give you the password, but I also need to give, well, I know my username is Malin, but I'll be ever more explicit. -u Malin -p. I'm going to go ahead and try my password here, and now I'm in. So -u specifies username, -p specifies your password. Not at the command line. When you hit enter, you're then asked for your password. And now this is the interface. I have just connected, essentially, to this port on the local server. Well, that's a bit of a white lie, because there's also a way of connecting locally through file sockets, but same idea. I've connected to CS75.net's database, and I'm going to go ahead and type show databases semicolon. You almost always need a semicolon. If you leave it off, you'll often be prompted again to fill it in. And then we'll see some stuff. So I've been playing around with mine over the course of the past several months. Information schema in MySQL is something you kind of get for free. You can hide it, but best not to touch it. Test is something you often get for free. It's just a playpen that MySQL gives you out of the box sometimes to play with. And then everything that's Malin underscore are databases I proactively created with a command called create database. So inside of these, let's pick a random one that we'll make our own in a moment. Let's see what I was doing in this lecture, some previous semester. So let me go ahead and type use, and then the database name, semicolon, just to be safe, though some commands don't require it. And now database has changed, so let me do show tables, another common command. So this is really, again, as simple as it gets. We're using pure ASCII art here to represent my rows and columns, and clearly this approach is not going to scale when my database gets bigger or my tables get wider. But here's my users table. So let me do this. Describe, because I'm curious, users, semicolon, and here we go. Tabular format, already rearing its head. Apparently I have two fields or two columns, but this program represents columns as rows just when describing them here. So we have a username, or user field, a pass field. Each of these is of type varchar, variable characters. So 250 fewer characters is the connotation there. Can it be null? No, neither of these fields. And then we'll discuss a little later tonight keys, one of which is in fact a primary key here. So if I wanted to now select some usernames, I could do syntax like select user from users. And this is sort of the canonical form. You execute a command from something, and then you maybe apply one or more predicates, filters, using a keyword where. And there's some other tricks as well. But this is just to give you a sense of what you can start to do with a database. So what I just typed were some SQL instructions. Not the use, not the... so not the use database, but rather describe users and select, and I can do things like this. I'll just give you a teaser. Insert into users. What do I want to insert? A user and a pass. What values do I want to give each? Let's do Malin, quoted, and then 1, 2, 3, 4, 5 as my password. Close paren, semicolon. Query OK, one row effective, really fast. So now, how do I see if Malin's been put into the database? Yeah, so select, let's just do star. Let's select everything. Select star from users, semicolon. Okay, so J. Harvard and Crimson was already there. Malin and 1, 2, 3, 4, 5 is already there. And just again, to tease you with some other functionality, you know what? I just care about Malin's password. So let's do select pass from users, where user equals quote-unquote Malin. So the nice thing about SQL, frankly, is that it's very accessible, and it's fairly self-explanatory. So now I'll get back just the pass field. And now there will be a PHP interface to this. So you're not going to have to execute, obviously, all of these commands manually. There exist APIs in PHP, in Java, in Perl, and any number of languages that interface with MySQL databases so that what you get back is not ASCII art, but rather an array, a PHP object, or something similar. And that's what we're focused mostly tonight. Yeah? I'm sorry? It's automatically committed when you execute select, unless you use something called transactions, which we'll talk about next week. But yes, the data is automatically saved to the database. Mm-hmm.
Do we have an editor or something for MySQL?
Yes, coming shortly. Yes, we have a much more sophisticated editor. You will rarely, if ever, have to play with the command line, but it's useful skills to have so that you're not dead in the water just because your GUI doesn't work. Yeah?
So I know you're saying that we won't have to deal with the user interface. But when you log in, you use your username and was that your username and password that was set up? So how would we have the name username?
Correct, your domain username, but in just a moment will we create new databases and you'll see how to create new usernames and passwords to use for individual projects. But yes, so I have, as my username on the system, I have access. If we configured the system, which is not uncommon, in such a way that username Malin has access to all databases called Malin underscore something, which is why you saw all of those databases there. So as a teaser for project 2 and 3, and probably your final projects, you'll have databases called, per the problem set's directions, username underscore project 2, username underscore project 3, username underscore FP for final project. And you'll create those via the panel interface, which I'll do in just a moment too. What I just rattled off is not a schema. Those are just names for databases. You will then create one or more tables within each database that adheres to some schema of your own design. Define schema here. Oh yeah, absolutely. But you will do all of this from scratch. So, and this is a good time to make one distinction. So, one of the lines we can draw between all of this jargon is a database engine is the actual server, the software running on the computer that allows you to connect to it with usernames and passwords. A database is just a piece of memory, disk and or RAM, that's been carved out for you exclusively under a username and password that you can create then multiple tables inside of. So again, the analog to sort of the familiar world is that a database is an Excel spreadsheet and individual worksheets are tables. So you will get one database. You will create for yourself one database, one big Excel file for each of the projects. So 2 or then 3 for the rest of the semester. And this is fairly common practice. So for all of the projects I've been demoing, like the Harvard Tweets, the news sites, all of those have their own databases so that every one of them is isolated from others for security reasons and just for mistakes. Lest I do something stupid on one, it won't affect the others. Yeah? No, it's not officially on the agenda, but very easy to discuss. So yeah, if not tonight, next week when we continue the discussion. Sure. Just remind me if I forget. Other questions? Okay, so a quick teaser then. Just one teaser to another. So this was the command line interface, but what you'll be doing in this course for creating databases is as follows. So we use, again, directedmin, which is this so-called web panel. It's one of the simplest ones out there, but cPanel and Plesk are other more popular ones that are names that you might come across. I'm going to go ahead and log into my account here. This is panel.cs75.net. And again, we've not needed many of the links on this page, but a new one of interest is now this one, MySQL Management. So I'm going to go ahead and click here, and you'll see just a GUI view of all the databases we saw at the command line. There's nothing interesting in any of these. I could delete them all. But what I'm going to do instead is create new database. And now I'm going to be asked for a few things. This is a directedmin convention. So the fact that I'm only being allowed to create databases called Malin underscore is just because that's what this software has imposed. On your own server, whether on your own laptop or desktop or server at work, you can call your databases anything you want. So just realize this is a convention to segregate 100 plus users all on one system. So let's do fall 2009. In there. Database username, frankly, my convention tends to be to use the same username as for the database because I at least tend to use one username per database, but that's because it's just me in a hotel room writing these projects. It's not multi-user projects for which we might want more usernames. I'm going to use a password of 12345 just for now, or I could associate this with an existing username. But again, this is just directedmin specific stuff, and that's it. That's all I'm going to use the panel for, just to create a database. All this did was execute a command like create database ... with some additional details. So you could do all of this manually or with other tools. So I'm just going to remember in my mind some of these details here because now I'm going to go over to cs75.net/phpMyAdmin. So here is the GUI tool that's promised. So coincidentally, the GUI tool we use in the course is called PHP myadmin. It's implemented in PHP. That's really just a coincidence, even though the course spends much of its time on PHP. This, frankly, is one of the best free open source tools that I've ever used almost on a day-to-day basis. It just takes the headaches out of managing a database and manipulating your data and viewing your data in a very user-friendly format. So there are plenty of other tools. In MySQL itself, exist Windows executables that you can run. They connect to a database. They give you rows and columns and buttons and menus and all of this fun stuff. This one's purely free. It's found on many commercial web hosting companies. And what's really nice from the course's perspective is because it has so many drop-downs and buttons you can click, as you'll see, it's largely self-instructive. If you're not sure, damn, what are the data types supported by MySQL? Oh, there they all are for me to choose from in the select menu. So it's actually a really nice way, honestly, in bootstrapping yourself to what's probably a new world for most of you, just because everything is handed to you. And there's much less futzing with manuals and with books. So I'm going to go ahead and log in here. I'm going to mention explicitly now the one nuisance of PHP myadmin in a certain configuration like this one is they did not implement cookies very well. And if you leave your session sitting there for more than an hour or two, you'll get weird behavior. The connection will time out, but it won't be clear that it does. So long story short, if you ever get weird behavior on cs75.net using PHP myadmin, when in doubt, just clear your cache or quit your browser and restart it. It's sort of a stupid bug in some of their cookie handling, and it happens if you leave your window idle for too long. So that's really the only headache we have with it. So I've just logged in. So most of these options on the main menu you won't need to touch, but if you become a database administrator, DBA, these are things that might be interesting to you because you can monitor the performance and you can configure privileges and stuff like that. So typically, for someone who doesn't use direct admin or a panel like that, you would actually create your databases either at the command line for people. You would create usernames at the command line and passwords at the command line for people. Or you use PHP myadmin, but because we're in the shared environment, we have that one additional step of the panel to get things started with the username with which to log in. So here I am. I'm rarely going to touch any of the stuff at the right-hand side there, but at the left, I have a little menu of all of my databases. I'm going to click this one. Parenthetically, it says 0 because I have 0 tables. I haven't done anything with it yet. So let me click that. And here's the interface. It's fairly simple. And again, this will be, don't think of this so much as a new tool to learn, but rather a way of learning MySQL and SQL itself. So let's create a new table. I'm going to keep it simple. I just need something to store usernames and passwords. So I'm going to call this users. How many fields? 2, though I sometimes screw up, so you can always add fields later if you get it wrong. And now I'm going to click Go. And now here it's prompting me, field by field, to to define the schema for this table. So the schema of a table is its design. What fields, what data type, what are the properties associated with each of these fields. So let me kind of replicate what I clearly had before, just because it felt like a good design. User field, a pass field. Now here are the data types, and we'll talk more about these in a bit, but here's a drop-down, and for now I'm going to go with the default. Varchar, which is a fairly efficient string representation in that it's variable length, which means if I type in 255 here, that just means a username can be up to 255 characters, but it will only use the database as few bytes as is necessary to store a username. So that's pretty good, but you pay a slight performance penalty. So these are, again, some of the design decisions for my little dinky website here. That's plenty fine. Password 2 is just going to be varchar. Collation has essentially some encoding stuff. You rarely will need to touch this. Realize that the folks who implemented MySQL originally were Swedish. So you will find sometimes that the default encoding has something to do with Swedish. That's not a problem. They use the same alphabet as us. So don't worry if you see that. It is not a problem. I'm going to leave this as blank so it chooses the default. That's called collation. And now here are some attributes. So what does this mean? Inapplicable for the field in question. We're using strings right now, varchars. But if we were playing with ints or integers, we could say it's an unsigned int. Or if we were playing with like a timestamp field, we could say anytime this table is updated, update the time in this field to be the current time. And that's a nice way of keeping track of when you modify your database automatically. This little drop-down lets me say, can this field be null or not? So one of the important principles in database design is integrity of your data. You don't want things getting messy. You don't want rows getting populated if they're partially blank sometimes. If you have a user in your address book, you might want all of those fields filled out or nothing at all, right? You don't want this weird middle state where you have some blanks in your data. And using properties like this, can you impose constraints? The database, for instance, if you say this field cannot be null, the password cannot be null, what that means is if you ever try to insert a username and a password, one or more of which are blank, the database just won't allow it. And it's a really nice way of putting error checking at your database layer and not just in your coding layer. And this works well, frankly, in the real world, where you often have divisions of labor, where you have a DBA, a database person, and you have developers. And the database person essentially asks, what data do you need to store? I will make you the ideal database. Here are your tables. Here are your fields. And then, henceforth, he or she just doesn't trust the developers and doesn't let them insert bad data into the database by imposing constraints like this. So it's a nice way of sanity checking yourself or others. Default, you can impose default values. If I don't want the password field to be null, but I want everyone to get a password, even if it's something stupid, well, this quote-unquote 12345 would mean everyone gets this default password. Not a good idea here, but it's possible. And then extra is just some other random stuff they couldn't fit into another menu. Auto increment is the one here. This is really useful. One of the things we'll talk a bit about tonight and also next week is the notion of keys and primary and foreign keys. Auto increment is a very nice way that exists in many database engines to allow you to assign every row a unique number, but you don't have to figure out what is the next available number. It just does it for you. So the first person gets 1, the next person gets 2, thereby assigning every row a unique number, which is quite often helpful if you don't have another unique field like an email address or a domain name, something that is more likely to be unique. Now these icons speak to things, again, we'll talk probably more about next time. Primary keys, indexes, unique keys, nothing at all, and full text search. So when you're designing tables, databases that have multiple tables, those properties become really interesting because they affect the performance of your database and also the constraints that impose structure on your database. And then comments is just some fluffy comments. But then lastly, and this we'll talk too about next week, you have multiple storage engine types. So in the file system world, we have things like HFS Plus and NTFS and FAT32 and FAT16 and all these other file systems. Storage engines is the analog in the database world. There are different ways to store rows and columns. The 3 tables that we'll discuss in the course or use are MyISAM. This is the most common in MySQL. It's very high performing, but it does not support what are called transactions. More on those next week. But it does support whole table locking, for those familiar. So that will have interesting implications for us next week. The memory database storage engine is neat because it means all of your data is stored in RAM. This is really good for temporary tables. If you need to keep some data in a database format, but you don't care if it's lost when the machine shuts down or dies, memory, aka heap tables, are really useful for that. And then finally, we'll spend time on InnoDB. It's newer than MyISAM. It supports these things called transactions. Not quite as high performing, but it tends to get corrupted a lot less often. And that's not to say the other gets corrupted a lot, but this is a really tight implementation of a storage engine. And there's bunches of others that are particularly useful for, actually, I don't even know what black hole is, but it doesn't sound like a good thing for your data. But there are others. Archive tables automatically compresses your data. We use these for a company I work for in New York because we have terabytes of data. This does the compression automatically. Federated tables are useful because this allows you to use multiple database servers or multiple tables and create the illusion of just one. So there's some really neat stuff in there that we'll only scratch the surface of for our purposes in the course. So that's PHPMyAdmin. I'm going to go ahead and click Save. Now notice what just happened for me, and just to make you realize that you're not really learning a tool, you're just using a tool to save time. All PHPMyAdmin did for us is essentially execute those pretty color-coded words at the command line. So the syntax for creating a table, which frankly is really annoying to remember, at least for me, is create table, quote unquote, the name of the table, dot the name of the, name of the database, dot the name of the table, open paren, and then a comma-separated list of all of the fields, which things can be null, which can't be null, the size of it. I mean, it's all very typable at the command line. It's just not very fun to start there. So PHPMyAdmin takes some of the headaches out of it, but realize it always tells you what it's doing so you can learn as you go from its help. Any questions? Yeah. Good question. Historical reasons. So for a long time, 255 was the maximum size for a varchar. People, myself included, have gotten into the habit of just using that if I have no opinions on what other size to use. But absolutely for something like this, could we pick something like 8, which is pretty common for usernames, or 16? It doesn't matter all that much here, and I just went with my memory of defaults. It's since been bumped up to like 65,000 characters for a varchar, so it's no longer that tight. All right, let's take a 5-minute break. All right, we are back. So it was pointed out, and this was completely my fault, that the syllabus says we would release the final project specification on like August 31st. And here we are in October, and it's not been posted to the website. So I'm glad someone said something, because I totally forgot that we didn't put the PDF online. It's not really to anyone's detriment, since the thing itself is still several weeks off. But I will go ahead and post that this week so that you know precisely what to expect. All of the dates have already been in the syllabus and all of that. So this document will simply expound on what's expected by the various milestones of the final project. But to be extra clear, especially on tape, do realize that the CS75 Finance, CS75 Fair is the culmination of the course, and this will be an opportunity not only for those of you who are regular attendants, but even for those of you who are distant, to join us in town here in Cambridge if you would like for 2 hours in December. The date and time specifically are on the syllabus, but it will be 6:30 p.m. to 8:30 p.m., and it will be joint with a class going on simultaneously across the hall. Dan Armendariz' own Exposing Digital Photography. And what we've done is booked a large room in the computer science building on campus. The idea will be to bring your projects and your own laptops over to the CS building that night. We'll have some Entenmann's cake and some milk and some other drinks and such. And it would be a chance, honestly, at the end of the semester just to mingle with classmates, see what they've done, because you'll exhibit each of your projects on your own laptop screens. Those students will exhibit their digital photography. Last year, one of their students actually brought in like a 24-inch LCD to really exhibit his work to everyone. But it was a nice way of, one, just having some cake last year, but also to get to know folks a little more intimately and to end the semester on a really sort of nice, gratifying note. So more of the details in that document. But what I thought I'd draw your attention to is not this document here, but this one, which looks similar. So for another course I teach, we similarly have started talking about final projects. And one of the most fun ways, I think, to start thinking about things you could do for projects in this course is actually to borrow some of the data we've been putting together for those students. And I'll link to this page on our own website, on the E75 homepage. But this is just a wiki page I've been putting together on fun APIs, some of which I've used, some of which I haven't. But one of the most fun things about programming for me, again, these days, is that there's so many interesting data sets and so many interesting APIs out there, whether it's Google's or Twitter's or Facebook's or any number of other ones. So we've started to consolidate them here with little descriptions, and even though that course is pretty different from this course, there actually is a good deal of overlap come final project. So the spirit of this course's final project is to really implement anything of interest to you, so long as it somehow draws upon the course's lessons. Doesn't mean that it needs to use HTML and CSS and PHP and JavaScript and Ajax and SQL and MySQL. Doesn't have to combine everything, but just one or more elements from the course. And there's a proposal process so that there's a sanity check where the staff says yay or nay, this is an appropriate idea. But most any of these APIs apply to what you could do at course's end. So what I do have in here is a link to the Twitter API, actually. And what you might want to do is glance at this page at some point soon, just for inspiration, especially if you had no idea that you could do some of these things the APIs empower you to do. The Facebook platform has its own API. We've got Google Wave here, Twitter, Google Checkout, and PayPal, both of which allow you to actually accept money for people visiting your website. Might be useful after the course. Yahoo Finance has CSV and RSS feeds. There's a graphics library here. We have a whole bunch of Harvard APIs. So what I've been doing in addition to these Harvard-specific websites is also been implementing some very simple REST APIs for them too. I haven't gotten around to the documentation yet. It's still coming soon, but it will be very similar in spirit to what you saw briefly tonight with Twitter. So long as you have a language like PHP that can make HTTP calls and can process the return data, that's how you'll interface with Harvard events and maps and tweets and news and all such other things. We actually have for that course too our own phone number, 617-BUG-CS50, and you can call that and use the interactive voice prompts and have Shuttle Boy, a program I wrote years ago, tell you verbally what the next shuttle schedules are. So even in this course too, if you'd like to do something that's server side but interfaces with telephone numbers, we have access to some other 617 telephone numbers if you'd like to do that as well. And then there's stuff down here on maps and photos, and we'll add to the list over time. So if you're one of those people who at this point have no idea what you might possibly want to work on, this is a really nice, fun place to start just for inspiration, if nothing else. And certainly solicit collaborators if you would like via the course's bulletin board, which is allowed as is mentioned in the syllabus. All right, so that's PHP MyAdmin. It is a tool. It will be hopefully both instructive as to what you can do with MySQL. It's fairly omnipresent, to be honest. In fact, those of you who did download XAMPP onto your own computers might have noticed already, or at least in its documentation, that comes with an installation of that tool too. So it's very popular, which is a good thing. So what can you do with SQL? So SQL is a query language. You may recall some discussions in the past few weeks of like XPath. XPath, as you probably did use, is a query language for XML. SQL is a query language for databases, specifically for relational databases, i.e. databases that are tables, rows, and columns. So it's fairly, as you've seen already at my little exercises at the command prompt, fairly self-explanatory. Definitely some new syntax and conventions you'll have to start to remember, but you pretty much tell the database to do what you want it to do left to right, word by word. So select, we've seen. Insert, we've seen. There's an update command where you can update existing rows if someone changes their password or updates their stock portfolio. Delete, we'll outright delete rows. We saw create for table, albeit in the context of PHP MyAdmin. There's alter, which would allow you to alter a table. PHP MyAdmin would automate that for you too, but show you what it's doing. Drop will outright drop a database. And ... There's some other stuff, but to be honest, with just these 7 and really these 4 basic building blocks, can you do most of what is common these days with database management? So with database use. There's some other keywords that follow these keywords, predicates like where, which I used, join, which is another popular one, but most of the juicy things you'll be using MySQL just in life with involves probably one of those 4 statements on a recurring basis. So where to get started? So MySQL has lots of documentation. I don't think it's very good. It's not very user-friendly, I would say. And I say this having just skimmed through some of it before class, just trying to find some simple answers, like what is the data type returned by the password function? And it wasn't obvious to me until I really did some digging. So I think, frankly, Google will be your friend with some of this stuff. PHP's documentation, definitely better, I'd say personally, than MySQL. But it is there. It is comprehensive. It's just written unnecessarily verbosely half the time. So with that said, notice the version number that we're using. So relatively recently did MySQL 5.1 come out, which was a fairly significant update to the database. We've shied away from updating CS75.NET for now, just because there really aren't features in that you would need for the course, and also we didn't want to rock the boat unnecessarily. And partly, the one downside of DirectAdmin, I would say, is that it essentially takes over your server and doesn't let you as easily use things like Yum or Aptitude. If you're familiar, it kind of does its own thing for managing software. So unless they have tested their panel with it, we don't necessarily benefit downstream. So there's some stupid real-world constraints, but 5.0 is very common, probably still the most common one, but realize we're trailing ever so slightly. And I'll say, too, on the server, we also are still, because of DirectAdmin, using PHP 5.1, even though 5.2 did come out. This will rarely affect you, but sometimes in the manual, you'll see in the documentation for some function, available since PHP 5.2, just realize that there might have been a new feature here or there. And if it's really something that's tripping you up, really it hasn't happened yet in the course, let us know and we'll do what we can. But these are just stupid real-world issues. It's either use DirectAdmin or not, so we chose DirectAdmin for its simplicity. So just to give you a taste of this, let me go ahead and just pull this up. And just because it is a useful reference to visit once in a while. So it looks a little something like this, organized by chapters on the right-hand side. Usually you'll just want to search for something. So I was searching, for instance, for the password function over here. Even their search engine kind of sucks, frankly, sometimes. End user guideline, I mean, set password. This isn't really what I want. Yeah, that's not what I want. So usually my SQL password. It's always, yeah, there we go. Okay, it's always funny when Google works better than the company's own search engine. But that's what I was looking for. So anyhow, Google is your friend with regard to this stuff. But to be honest, I don't think you'll often need to consult the manual. There are many better tutorials online. So if you're looking to learn SQL, the language, not MySQL, the product, you consult the resources page of the course's website, where we offer a link to a number of tutorials. And if you procured or borrowed either of any of the course's recommended books, a SQL book is not a bad thing to have, because it's fairly, it lends itself to quick reference and less to, say, exposition. So make a mental note of that. So what can you do when designing tables to ensure certain properties exist for your data? So there's these things called indexes in databases, and this is what makes them far superior for large websites and large projects, certainly, than just flat ASCII files, CSV files, or XML files. With any of those latter file formats, you don't have any fancy data structures that expedite searches and sorts or any of that. Everything is done from scratch. Everything's read from disk into memory, then removed from memory, then you repeat the next time the user clicks a link. Not very performant. But in a database engine, you can not only keep all of your data resident in RAM, if your computer's physical resources permit, you can also have the database using very sophisticated, smart algorithms that sophisticated, smart people have come up with at MySQL, the company, and other places like Microsoft. You can let the database optimize itself for common functionality, like searches and insertions, because you can provide hints to the database that, you know, this field is one I'm really often going to search on. Why don't you create for me an index, which essentially is a fancy data structure, like a hash table, that expedites searches on that field, tries to achieve, say, constant time lookups instead of linear or something worse than that. So you can specify for almost any field in a table whether it is an index. So if you click the appropriate icon in phpMyAdmin, or you use this keyword when creating or altering the table, you can say, MySQL, index this field. In other words, spend some additional bytes, come up with a fancy data structure, it's usually tree and structure, that optimizes searches on this field. Now what does that mean? Well, when I did that very simple query, select pass from users where user equals quote unquote Malin, which field was I searching on, essentially? The user field, so the username field. So had I designed this table with an index on username, that operation, that search, would be a lot faster with the index than without. The downside is you'll spend more disk space, and how much disk space depends on the amount of data. Frankly, I can't really simulate the benefits of using an index when we just have Malin and J. Harvard in our database, but you can always make this decision after, too, and that's what these icons are useful for. So notice, previously, all I did pretty much was create the table. Now let me draw your attention to some of the tabs. Fairly self-explanatory, but the two most common ones, perhaps, are Browse. Clicking Browse lets you see what's inside of your table. Nothing at the moment, because we haven't inserted any data here. So let me do this, just to make clear the connection between these. I'm back at the command line. I'm going to say use Malin 2009. Let's see. I might have changed something here. Let's see. Use Malin. Fall 2009. There we go. Okay, just typo error. Okay, show tables. Okay, there's my users. Describe users, and this is the one we just made before the break in phpMyAdmin. Okay, so now I have nothing in there. Select star from users. Nothing. Now, incidentally, capitalization doesn't really matter. I would say, and I would encourage from personal experience and convention, that capitalizing SQL keywords, but keeping lowercase your field names and your values is a good thing, because when reading your code, when reading instructions, it's very clear what is simply syntax and what is actually interesting data. I would say this is not uncommon, this approach, but I could have just said select star from users. Doesn't change the behavior. So let me do an insert. Insert into users. What fields do I want to insert? I want to insert user and pass, followed by what values? Well, let's put J. Harvard into this new table, because he was only in 2008s there, so crimson. And then semicolon, run what row effective. I'm going to hit up a couple times to go back to this. Okay, so now someone's in there. So it occurs to me now later, damn, I really should have made this a index so I can expedite searches on that user field. So let's browse for this data. Now I've clicked browse, and now I see a tiny little table because there's not much data in there, but I can visually see what's in this table. So this again is much prettier than the ASCII art. I can click the pencil if I want to modify it, and it's honestly...
Okay, so could not connect to database. Well, that's because, and you can see this perhaps in your source code there, in login5.php, I've got this. Connect to the database using empty string, empty string, empty string. So we got to fill in those blanks. One is supposed to be the name of the IP address or host name of the database. Number 2 is my username, and number 3 is my password. Clearly, all 3 of those are blank. So let's fill in these blanks. Well, we've been a little preemptive here, so we were already in our database. So I know I have a database called Malin Fall 2009. So let's use that. So let me go ahead and fill in one blank. My host name, for this case, is going to be localhost, because I'm on cs75.net. If you're developing at home, localhost should also work, or the more arcane, 127.0.0.1, which is your loopback IP address, which should also work, but I'll go with the more common localhost. My username is Malin_fall2009, and then my password was 1, 2, 3, 4, 5. Right? We just hard-coded that when we created my database with the panel. So, takeaway here is for project 2, you create your database per the PDF, you write down or remember your username and password, then you start writing some PHP code eventually, you've got to plug in those values somewhere. Because this is a self-contained demo, I'm putting it in the .php file here itself. Better practice probably is to use a config.php file or define these things as constants elsewhere and start requiring them or including them at the top of the file. So more on that to come. And incidentally, before I forget, there is in fact section tonight, across the hall, same time, same place, which will focus on SQL and other such fun things here. Okay, so now I've got this. My font size is big, so it's wrapping in an ugly way. But I'm just doing a little draconian approach. So dying in PHP speak, not the best way to inform users of your errors. You should do things more elegantly. I'm trying to focus on the essence here, so I went with the quick and explanatory die. Now I have to select my database. So because the server can actually host multiple databases owned by multiple users, I need to say, I now want the Malin Fall 2009 database specifically. So the 2 new functions in our arsenal are MySQL Connect, which connects to the database, and MySQL Select DB, which selects an actual database. This is a slightly older API, realize, that's been with PHP for some time. There's a newer API called MySQLi. Intermediate, I think, is the I. It's more sophisticated, but it's also not as easily learned the first pass. So we still focus on this version. For your final projects, by all means use any API you want. There's another one called PDO, which further abstracts away and is an API that exists in other languages too. But I think you'll find that this API, though limited, is very simple and easily picked up. So even I still use this with almost all of my projects just because it's so easy. Okay, so now the rest of this code is actually pretty much the same until I actually need to check username and password, at which point I'm going to have to ask the database a question. So let's see if I've done some good, at least by filling in those blanks. Here's my web page again. Let's close this, go back here. I'm going to reload. Whew. Okay, problem gone. So this means I hit reload, I connected to the database, I selected the database, now it's time to actually provide some data. So what's going to happen? Well, let's head off any future problems. So if the user has submitted the username and the password field, so both of those variables are set, remember the same logic from weeks ago, I need to now check, is the username equal to the username that we support and the password equal to the password? But we're going to now do this dynamically for any number of users, not just state hardware. So here we go. If you are wondering how you embed SQL code in PHP, there's a number of ways to do it, and I would say one of the simplest ways early on is with this approach here. So sprintf is a function in PHP and in other languages that generates a formatted string. And what's nice about this is sprintf allows you to pass in a string as its first argument, and then a comma-separated list of variables that get plugged into placeholders in that string. What do I mean by that? The following. So I am creating a string with this function, and it's going to return the string and store it in a variable called SQL. I'm going to create this string. Select star from users, where user equals quote-unquote %s. %s is a format code derived from the world of C and C++ years ago. It means put string here. What string? Well, the comma at the end of this line says, okay, put the value of the following variable in that location. Now, why did I factor it out? Well, we'll talk about this in more detail next week, but there's these things called SQL injection attacks. Very common. Even I, between last semester and this semester, usually just for fun, when I'm on someone else's website, I see a web form, I often type in bogus data just to see, will this break? Because if it breaks, 9 times out of 10 it's because they're not being smart like this. So this is the reason for this apparent complexity. The variable I'm going to plug in is not what the user typed in. It's going to be the result of escaping what the user typed in. In other words, there are dangerous characters in SQL, like in lots of contexts, like the single quote is bad. The keyword delete is bad. The keyword drop is worse. You don't want users to type in a username of drop table and as though that's their username, lest you've got to pass that to the database engine and bad stuff happens. And this is totally legit, and I'll tell you a little tale perhaps once I've pondered the ethics of my last time when I found little SQL exploitation attacks. We'll learn that next week perhaps. You can get into servers unbeknownst to the programmers because they've done very simple, stupid mistakes. So I'm already warding it off, even with this toy application. So unfortunately, the MySQL or the PHP folks thought it would be a smart idea to name a function MySQL underscore real underscore escape underscore string. And we're stuck with this mess. But this is the function you call to pass in a string and change any dangerous characters to non-dangerous characters. So you just call it. And among the things it does, honestly, is tackle quotes and things like that. So I'm passing it the value from the post superglobal called user, and this just takes care of these things called SQL injection attacks. And we'll actually discuss this in more detail next week, but for now, this is just a good model habit to get into. Prepare your SQL string using sprintf, though there are other ways, then call MySQL query, passing in the string to MySQL query. So what that line of code there does is this is equivalent in PHP code to copying and pasting this string into PHP myadmin or to that command line interface, hitting enter, and what's going to come back now is not the row or not the rows, but rather a result set. And this is SQL speak. So a result set is an object whose structure you don't necessarily know, but inside of that object are the 0 or more rows that match your query. So what you now need to do with this result set is ask it, this little black box, give me your first row. Then ask it, give me your next row. And then give me your next row. And when it finally returns false, then you know it's out of rows. So it's like an iterator, if familiar with the construct. So here's what I do. If result equals false, this just means I probably had a syntactical error. I had a stray piece of syntax, or I misspelled the word select, or I specified a table name that doesn't exist. If MySQL query ever itself returns false, that does not mean there's 0 rows. That means you screwed up, and you asked it a question it cannot answer. So, if it's not false, we proceed, and I check if the number of rows in the result set equals 1. What is the implication logically? Sorry? So I'm going into the loop, but just bigger picture. If I execute select star from users where user equals something, I found the user. I found the user whose username was input. If it equals exactly 1. Now, if it equals 0, that means what? No record. The user just never registered for my website or whatever. If it returns 2, someone screwed up. It was probably me. If I have 2 people, 2 rows with the same username, I shouldn't if I make the user field not just an index, but rather what kind of... Yeah, so if I actually make it, let me go back to my structure for users. Click this. So if I actually make it not just an index, so I'm actually going to kill the index because I don't want it to just be searchable quickly. I want to make the username unique, but then also what I could do is make it a primary key. So it's the same thing in this context, but for now I'm going to say make this a primary key. And for now, and we'll revisit this topic, when you have a field in a database that uniquely identifies each row, the thing that's supposed to be unique globally across the table, that is known in database worlds as the primary key. It is the field you can look to uniquely identify a row. Now that doesn't mean other fields can't also be unique, because what you'll often find is you were hinting, we're going to get away from this idea of using user names as the unique field. We'll go to user IDs, like you number, because then we can use 32 bits consistently and not variable length strings to find people. We can just look up their ID. But even then, we probably want a primary key to be this unique number for efficiency, but we still want the username to be unique. So you can have one primary key and then another unique index, and maybe another unique index on email address, which should also be unique generally. So there's different features possible here.
So you have to delete the index?
I didn't have to, but it was just redundant. I'm taking up space and I'm gaining nothing from it. So I was just cleaning up my mess there. And for the camera, that's why I deleted my index. Okay, so let's see. We're almost done with this story. So if I found the user, one thing remains. What do I need to do? Check the password. So I've said select star. Star denotes every field. So what I now get back conceptually is a row from the database representing Malin or J. Harvard or whoever I asked for. What does that mean to get back a row? Well, in PHP, they chose to represent a row as an associative array. I can now get at the user field or the pass field or any other fields in there by way of the square bracket notation, which is really convenient. So let's do it. Here we go. So the function to fetch an actual row from the result set from that black box is called MySQL fetch assoc, or fetch associative array. There are other versions. There's MySQL fetch array, which just returns an array that's numerically indexed. So you have to remember that the field 0 is user, field 1 is pass. That's better for performance because you need less metadata in the row that's coming back, but it's kind of a pain to code against. And if you ever restructure your table, you then have to remember to go change all of your code and all of these assumptions you made about the numeric location of the fields. So personally, I almost always use associative return values because it's safer long term, even though you pay a slight performance benefit penalty. If you're implementing the next YouTube or Facebook, fine, maybe then you can quibble over numeric indices. For most projects, associative arrays are safe. So I get the row. And now I should only call this function once because I already know that my SQL numRows return 1. If I called this again, I would get back false because I'm at the end of the cassette tape, the end of the result set. So it's again, an iterative process. So now I check, is the pass field in this row equal to what the user typed in? If so, set this session variable to true, and then do this other stuff where I redirect the user and blah, blah, blah. Same code as 2 weeks ago. Done. So the only addition here to this week was we added the database. We manually created the user, J. Harvard, Malin, whomever, and then we just updated our code, not to check the user's input against those constants, but against the return values from the database. But there are other ways to do this. So I took the approach of selecting star from the database. Could I have done this differently? Sorry, just what? Okay, so I could just say give it the field name. So equivalent to star here, just to be clear, because I don't think I did this before, I could also say select user, comma, pass, comma, any other fields I want. So you can be explicit. And in general, selecting star might be okay, but it's also a bit lazy. Why ask for more data than you need? You're just wasting memory and wasting time. So probably not necessary.
Can you repeat one more time how this MySQL really skips to will help not deleting the database or dropping the database?
Sure, and actually, let me defer the best answer to that when I have some visuals next week. But the short of it is that if I have a form like this, generally the user is going to type in Malin and then a password like this. But you don't want the user to type in something like drop users, semicolon. And because, notice what we're doing. We are taking the user's input, and then we are creating via sprintf a string containing that user's input. So even though here that wouldn't really make a difference.
So would this be the kind of false statement, false or something?
No, what it does is, so this command alone will not harm my database. Just saying drop users, it becomes dangerous if the user knows that you're using single quotes somewhere and says, you know what, this drop user statement is going to get sandwiched in between. Let me scroll to my string. It's going to get sandwiched in between these quotes. So you know what, let me really mess with them. Let me close that first quote for them like this. And then I can say something like, or 1 equals, quote-unquote, 1. And this, actually, I'm not going to drop my tables in this case. This crazy-looking thing, because I know it's going to get sandwiched. Oh, wait, typo. Because I know this whole thing is going to get plugged into where the %s is, which is flanked by single quotes. Notice I've just made a really pretty string where I'm saying, No, this doesn't work here. See, this is why I wanted to say this for next week when I actually have the right context. No. Yes, this does work. This does work. So I'm asking select star from users where user equals this string. Because I'm plugging in this crazy looking thing, I'm making a vacuous truth. I'm saying select star from users where quote unquote. Yeah, where quote unquote.
Basically, you need to close the code and then you need to add one equal, right?
No, this works though, because single quotes will evaluate to false. So this is now saying where quote unquote or 1 equals 1, and the second of those conditions is always going to be true. 1 always equals 1. So the whole resulting string will say, give me everything where 1 equals 1. That means you just got back the whole row. Now in this case, because we're doing this on the fly, it still doesn't help because my code is still checking for results that equal to size 1. And if I get everyone from the database, odds are that's not going to be the case. But long story short, what my SQL real escape string does is it does stuff like this. If the user types that in, that's fine. They can do whatever they want. It's going to escape every one of those dangerous characters so that you can't mess with the syntax of my query. But again, I can do this better justice with the right context next week, but that's the gist of it. Okay, so the question at hand was, can we do this differently? Well, we're really not using the database for what it's good at. Databases are good at finding data. I don't need to take the burden on myself to doing these comparisons. Why don't I do this? So I'm going to go ahead and go into login6.php. I'm going to scroll down. And you know what? Why am I doing the comparison? Let this stupid database do this for me. Select one from users where user equals something and password equals something, right? Just make the database check both fields for you. And this is just a clever trick. I don't even need to get the username back. I don't need to get the password back. I already know what they are. I just need a yes-no answer. So this clever trick here says return to me the value 1 if you find a user matching the user's name and a password matching the password's name. So what you get back here is essentially a temporary table. When you execute select, what you're getting back are tables or subsets of tables. So you can create essentially tables on the fly. What this will return, if I find J. Harvard in Crimson, is a 1-row, 1-column table containing the number 1. But this is really interesting for me because 1, it's very efficient. Really hard to store less than this in a table. And now I can check if I in fact got back a row. Well, that meant what logically? That the username was found and the password was found in the same row. If, however, I can't find J. Harvard or J. Harvard with this password, this query is going to return how many rows? Well, none. It's not going to select 1 because it failed to match that predicate, so I don't get this back. I get nothing back, so my SQL num rows return 0. So this, again, is just a very clever trick, pushing the logic, pushing the search functionality into the database where it really belongs at this point. And again, I've solved this problem a little more elegantly. Now, we barely scratched the surface of what you can do with this, but hopefully now you have the right mental model, some basic syntax. We'll continue to have more advanced features next week, as well as some of the security threats. And for now, if you can stick around, we have Sid next door in that section. See you next week.